Business Calculus, Topic 7, Homework Problem number 30. We have the graph g of x equals x cubed minus 12x, and it's bounded between -4 and 4. So here's -4 to 4, and so it stops here and here. And here's the actual graph. Now, we want to find out, indicate the x and y intercepts, and order your answers from smallest to largest, and then from smallest to largest for y. If the answer doesn't exist, just enter does not exist, D and E. So first we'll find the x-intercepts. We find x-intercepts by setting the original equation equal to 0 and solve for x. I can factor out an x here as a GCF, and I'll have x squared minus 12 equals 0. And then when I solve this part right here, this is x equals 0. For the second part, x squared minus 12 equals 0. This implies x squared equals 12. And this implies that x is equal to plus or minus the square root of 12. Typically we simplify that, but for the computer sake, we'll leave that as the plus or minus square root of 12. Now, in order, the first x-intercept that we'll run into is the negative square root of 12. So this will be negative square root of 12, comma 0. The next one will be this one right here, x equals 0. And the last intercept will be positive square root of 12. Lastly, we need the y-intercept. We find the y-intercept by making all the x's 0. So x cubed minus 12 times 0, or 0 cubed times 12 times 0, and we'll have g of 0 equals 0. So the y-intercept is 0, 0. Okay, next. We want to indicate the extremas. Well, to find the extremas, the max and mins, and we're putting that in largest to highest, we want to take the derivative of g of x. So the derivative of g of x will end up being 3x squared minus 12. And then we'll set the derivative equal to 0 and solve for x. So if we factor out a 3, this will leave x squared minus 4 equals 0. This factors into 3 times x plus 2, x minus 2, and we get two possible extremas, negative 2 and positive 2. Okay, now, here at negative 2, I see this is a max, right there. And here at positive 2, I see this is a min. Okay, so we need the x and y value. So we want to take the smallest one, which is x is negative 2, which is a min. So this is x is negative 2. And we need the y value. So I'm going to take the negative 2 here, and I want to put it into the original function, g of x, which is negative 2 to the third power minus 12 times negative 2. So this will be negative 8, and this will be positive 24. Alright, and when I add those, I'll get 16. So g of negative 2 will be 16. So it's negative 2, 16. Okay, and that's one of my, I'm sorry, that's actually my max. So let's move this down here to max. Negative 2, comma, 16. And let's look for the min, because 2 was the min. So when I put 2 in here, this will be positive 2, which gives me positive 8, positive 2 here, which will give me a negative 12 here, and I'll end up with a negative 16. Okay, so 2 comma negative 16 is my min. Alright, so I got a max and I got a min. Okay, and those are the points here. This is point is negative 2 comma 16, while this point is 2 comma negative 16. Okay. Next, are there any other? Let's see. I got a min value here, min value there. Alright, oh, my endpoints. Now here, in fact, this is my lowest min point right here. Goes as low as negative 4, so I have to put negative 4 into the function. G of negative 4 equals negative 4 to the third power minus 12 times negative 4. And this will be negative 64 and positive 48. Okay, that'll give me a negative, let's see here, 2, 6, 16. Okay, so that point right there is actually a -4, -16. It's pretty low. So that's actually my lowest minimum. So I'm going to change this one more time. Alright, so -4, -16. Okay. Then my maximum here is 216. Then my next min is down here, which is 216. Let's put that here. To -16. And then another max, which is right there. That's where x is 4. So let's go put 4 into the function g. And put a +4 here. I'll end up with a +64 and a -48, which will give me a +16. So that'll be 4 and a +16. So my maximum here will be a 4 and a +16. Okay, indicate the points of inflection. Well, inflection points come from a second derivative. Sorry about that. So I can fix that. Okay. Inflection points come from a second derivative. So let's take another derivative of g. And the first derivative gave us 3x squared minus 12. So the next derivative is going to give us 6x. Having trouble with the camera here. Okay. And we'll set 6x equal to 0. And this implies that x is 0. So we have an inflection point right here at 0. If I put 0 into the original problem, g of x equals 0 to the third power minus 12 times 0, we get an output of 0. So the point here will be 0, 0. And that's our inflection point. Okay. Now, looking at the end behavior. As y goes to as x goes to 0, let's see, as x goes to 0. As x goes to 0 right here, this direction, y actually goes to 0 because it ends up right here, so that's no good. As x goes to positive or -4, so as we go to +4 here, or we go to -4 right there, or +4 over there, the answer for y ends up being 0, so that's not bad. As x goes to positive or -4, do we get positive infinity? So no, we get 0, so this is bad. And as x goes to -2, so we'll go to here, and we'll go to this spot right here, to those two spots. It looks like y is about maybe 20 or -20, definitely not positive infinity, so this is not usable. Alright, so indicate the behavior at infinity. So as x goes to positive or negative infinity, what's happening? As x goes to positive infinity, right here, we see that y is going to positive infinity, but as x goes to negative infinity, y is going to negative infinity. So this one can't be true. Here, as x goes to positive infinity, which is over here, do we have y going to positive infinity? And x goes to negative infinity, does y go to negative infinity? Well, yeah. As x goes to negative infinity down this way, y goes down. As x goes to positive infinity to the right, y is going up. So this one looks good. So as x goes to positive or negative infinity, do we get y going to negative infinity? Well, as x goes to the right, y goes to positive infinity. Ooh, so that doesn't match because we need to go to negative infinity. So this is bad. Now, as x goes to negative infinity, which is to the left, do we get positive infinity out of y? No. So as we go to the left, we get negative infinity. So this is garbage as well. So this is the only good one right here.